In this video that's part of Unit 3, we're going to take a look at the section of 3D electron configurations and start to understand the theory behind predicting the shape and arrangement of energy levels with electrons in them. So our objectives here are no energy levels 1 through 7. Orbitals are designated S, P, D, and F according to their shapes and the regions of the periodic table. So we're actually going to map that out on your periodic table. That's one of the questions right down here after our definitions. And we're going to know that electrons are added one at a time to the lowest energy levels first. That's the Aufbau principle, named after the scientist Aufbau. And then electrons occupy energy orbitals, so the maximum number of unpaired electrons results in maximum of 2 electrons, the Pauli exclusion principle. So we're going to find out that electrons come in pairs and they rotate in the opposite direction. So the reason why we're going to look at first, what is meant by the electron configuration of an atom is the arrangement of electrons within the electron cloud. It's based on the energy which each electron possesses, and this is dictated or predicted by the uncertainty principle of Heisenberg, that one cannot know both the position of an electron in space and its energy at the same time. So the closer you are to getting the exact position recording, the further away you are from being able to measure its energy, and vice versa. In terms of electron configurations, what does each of the following mean that you must or cannot do? So with the uncertainty principle, we cannot know with certainty both the energy and the position of the electron at the same time, because electrons are very small and their quantum physics is their scale, so they don't act like macro scale, like what we see around us. They're very, very tiny, so the act of actually measuring them causes them to change. Strange but true. The Aufbau principle is going to help us map out our orbital diagrams down below, but the sublevels must be occupied from lowest to highest. So you read the periodic table left to right by period, like a sentence, like a paragraph, and then you just add electrons at a time and you fill them up according to the very distinct number of electrons that can be in each orbital, and the periodic table tells you that as well. Hund's rule, another scientist's name, all orbitals within a sublevel must be occupied with one up arrow. So we're going to designate orbital diagrams with up and down arrows, and then before any may be fulfilled with the down arrow within a sublevel. So a good way to remember that is everyone is a bachelor before they can be married. Marriage comes in pairs. The Pauli exclusion principle is the electron with the same orbital must be of opposite spins to avoid electron-electron repulsion, because remember, subatomic particle electrons are negative and negatives repel each other. And then you must have the upward facing arrow that indicates the spin of that electron may be full before they pair up within a level. So in this world, males may live with females and never up or down. On the periodic table, clearly indicate by outlining the S, P, D, and F blocks. And so this is what it wants you to do. So the S block is going to be outlined in black. That's our groups 1 and 2, our main group elements, and then the carbon families through the halogens and the noble gases. And then the P block is right here. The D block is our transition metal block. The F block are lanthanides and actinides. And we're going to use those to fill up. Now remember, the F block fits in here and would make the periodic table very long if we looked at it in structure. In the next video, we're going to take a look at these proper number of electrons in a period.